So hello students. So right now in this class we will discuss about the last theme of this topic, that is salt hydrolysis. Little bit of elementary idea is given in your syllabus. So let us understand what is the meaning of salt hydrolysis. That clear? So first one, that is salt hydrolysis. Salt hydrolysis. So salt is nothing but the mixture of an acid with a salt. Acid plus base giving rise to salt plus water. So this genuine process is known as neutralization. This process is called neutralization. And here we are discussing salt hydrolysis, that is the reverse of neutralization. The reverse of neutralization means salt plus water giving rise to original acid and original base. This process is called salt hydrolysis. Salt hydrolysis. So you can say the neutralization and salt hydrolysis are complementary to each other. That clear? Now you see the interaction of salt with water to produce original acid and base is called salt hydrolysis. Clear? So salt hydrolysis definition can be written as the interaction of salt or the reaction of a salt with water to produce the corresponding acid and base, is called salt hydrolysis. Is called salt hydrolysis. That clear? So most commonly, if I consider a salt Ba, this one is salt plus water, H2O, water, giving rise to acid and base. Acid, that is AH, acid plus base. So in salt there are two parts, you know. One is cation, another one is anion. So Ba, I can consider this one is B plus A minus. Okay. So in water, its dissociation can be written as H plus OH minus. So the interaction of cation of the salt with OH minus leading to base, and the interaction of anion of the salt with H plus of water leading to acid. So what is the definition of salt hydrolysis? It can be defined as, again, salt hydrolysis can be defined as the reaction of the reaction of, or you can say the interaction of, that clear, the reaction of cation or anion of the salt with water to produce either acidic or basic solution is called salt hydrolysis. Is called salt hydrolysis. Salt hydrolysis. You see, in order to understand this statement, if I consider, okay, so more generally the salt hydrolysis BA, this one is a salt plus H2 giving rise to BOH, this one is base plus AH, this one is acid. So in first case, if I consider base as a strong base, okay, so you know the strong part is 100% ionized, so salt definitely its complete ionization leading to B plus A minus, water very weakest electrolyte remain as such. Again, if I consider this basic part, this alkaline part is strong, then I can write B plus OH minus. Since acid this one is weak, I can write it as such, AH. Clear? Now you see in both sides this B plus get cancelled, and the final equation A minus plus H2 giving rise to H acid plus OH minus. So what can you say over here? The resulting salt solution produces OH minus ion. So this is alkaline in nature. The result salt solution is alkaline in nature because of producing OH minus ions. And here you see the anion of the salt participate in interacting with water. So this is also called anionic hydrolysis. Since the anion interacts with water to produce alkaline salt solution, this is called anionic hydrolysis. This is called anionic hydrolysis. Clear? Like that of, again if we assume the produced acid is taken as the strong component, then what we will see right now. So now if we consider this one as strong, then the equation can be written as B plus A minus plus H2 giving rise to, this one is weak, it remains as such, plus A minus plus H plus. And look at over here, this A minus get cancelled. The final equation B plus H2 giving rise to BOH plus H plus. Here you see free H plus ions are produced. So the resulting salt solution, that is acidic in nature. The salt solution having H plus ions, hence it is acidic in nature. Hence it is acidic in nature. Since the cation of the salt, since the cation of the salt interacts with water, to give acidic salt solution, this type of hydrolysis is known as acidic hydrolysis. Okay, this type of hydrolysis is known as, you can say, cationic hydrolysis. Cationic hydrolysis. So this is the detail about the meaning, what do you mean by salt hydrolysis. Clear? Let us discuss about the hydrolysis of salt of a different category. So first one, if I consider hydrolysis of salt of strong acid and strong base. So strong acid, if I consider hydrochloric acid, this one is a strong acid, interacts with a strong base, sodium hydroxide, strong base, acid plus base, definitely leading to the formation of salt and water, NaCl corresponding salt plus water. This is a neutralization process, and here we are considering this type of salt. So sodium chloride is a salt of strong acid with strong base. Clear? Now let us represent its hydrolysis. NaCl plus H2O giving rise to corresponding acid and base. So acid, that is NaOH, strong base, plus HCl, strong acid. Clear? So let us represent its ionic form. The salt, 100% ionization, strong electrolyte, Na plus Cl minus, plus H2 weaker one. Again this one is strong, you can write Na plus OH minus. Again this one is strong, H plus Cl minus. Right now Na plus get cancelled, Cl minus get cancelled. So only there is the dissociation of water or the ionization of water, H plus OH minus. So there is no interaction of any cationic and anionic part of this salt. Is there any Na plus? No. Is there any Cl minus? No. So there is nothing, the part of salt involved in this process. It only involves the slight dissociation of water, H plus OH minus. And here there is no change in pH. pH almost remains 7, that is neutral. So the resulting salt solution, is neutral in nature, Clear? Because no cationic and anionic portion of the salt interacts with water. You can write over here, no cation or anion of the salt interacts with water. That's why the resulting salt solution is neutral in nature. Now let us discuss about the hydrolysis of salt of weak acid with a strong base. So salt of this category, tell me students, weak acid, let's say acetic acid, this one is weak acid plus strong base NaOH, strong base. Clear? Definitely the salt is that is CH3COONA, sodium acetate. Is that clear? This one is your salt, corresponding salt for the hydrolysis we'll discuss right now, plus salt and water. This is neutralization process. So let us discuss its complementary step, that is salt hydrolysis. CH3CONA, salt, definitely this one is strong, with water. Salt hydrolysis giving to original acid, that is CH3COH acid plus base, that is NaOH. This is base, and out of these two you tell me this salt is strong, this one is weak, this acetic acid is weak, while this NaOH is strong. Right now you can represent more precisely the step of hydrolysis, that is CH3COO minus plus Na plus H2O giving rise to CH3COOH plus Na plus OH minus. Clear? Now this Na plus get cancelled, so the salt solution is definitely alkaline in nature. CH3COO minus plus H2O giving rise to CH3COOH plus OH minus. The salt solution is alkaline in nature. Alkaline in nature. Clear? So always remember the weakest portion of the salt undergoes hydrolysis. So what are the main components of a salt? One is acidic part, another one is basic part. One is cation, another one is anion. So here you see in this salt the weakest component is acid and strongest component is base, and in the final expression the weakest portion interacts with water. The weak part undergoes hydrolysis. Okay, you can write over here the weak part of the salt undergoes hydrolysis. Clear? Now let us discuss the case about weak acid and weak base. Let us discuss the hydrolysis of salt of weak acid with a weak base. So weak acid I can consider over here acetic acid, weak acid plus weak base ammonium hydroxide. Weak base will give you corresponding salt of weak acid, weak base CH3COONH4 ammonium acetate, as your salt plus water. Clear? So now let us consider the hydrolysis of this salt. CH3CO minus plus NH4 plus strong component, salt, water, giving rise to CH3COOH weak acid plus NH4OH weak base. So right now just see the final salt solution can be acidic or basic, or it can be neutral. It depends upon the strength of weak acid or weak base. If the strength of weak acid is more, then the final solution can be acidic in nature. If the strength of weak base is more, the final solution can be alkaline in nature. If both the weak components, that is weak acid and weak base, have same strength, then you can say the resultant solution is neutral in nature. Okay, so in this case the weakest component, that is weak acid, that is acetic acid, clear, and the weak base, that is NH4OH, both have same strength. That's why the resultant salt solution is found to be neutral in nature. But as per I have told you, it depends upon the strength of the results of final solution. The results of final solution depends upon the strength of weak acid or weak base as per the case is concerned. That clear? So these are the elementary idea about what do you mean by salt hydrolysis and hydrolysis of salts of different categories. Clear? Okay. Now let us discuss what do you mean by hydrolytic constant. Hydrolytic constant, this is represented as KH, hydrolytic constant. Clear? Suppose I am considering a salt Ba plus H2O giving rise to BOH plus H, or H, that is acid, AH. Clear? Now if I am writing equilibrium constant K equilibrium, that is equal to the concentration of base, concentration of acid upon concentration of salt into concentration of water. Clear? So now this K into the concentration of water, that is equal to BOH H upon BA. So you know the concentration of a water is always constant. So overall I can write KH, hydrolytic constant, that is BOH H divided by the concentration of salt. So this is the expression for hydrolytic constant, that is called KH. Now another term, that is degree of hydrolysis. Degree of hydrolysis. Degree of hydrolysis. Clear? So degree of hydrolysis means it is the total amount of salt, or you can say the percentage of salt. Okay, percentage of salt that is hydrolyzed, which is hydrolyzed, So hydrolytic constant H can be defined as number of moles of salt hydrolyzed upon the total number of moles of salt taken. Total number of moles of salt taken. This is the expression for degree of hydrolysis, that is H. Clear? Now let us find out, discuss, although it is not in your syllabus, but you should know how the formulas are derived. Let us consider the case hydrolysis of salt of weak acid and strong base. So salt of this category, you know, that is nothing but your CH3COONA. So its hydrolytic equation can be written as CH3CO minus plus Na plus water giving rise to CH3COOH plus Na plus OH minus. So Na plus get cancelled. So the equation is CH3CO minus plus H2 giving rise to CH3COH plus OH minus. So this one is your hydrolytic equation. Then another equilibria possible. The other equilibrias possible in the solution, that is, so weakest component acetic acid is there, CH3COH, CH3CO minus plus H plus. Clear? So here you can write here KH hydrolytic constant, that is equal to the concentration of CH3COH into concentration of OH minus. Water is taken as constant, just I have discussed. Right now for this one, acid dissociation constant Ka, that is equal to CH3CO minus H plus upon CH3COH. Clear? Now another equilibrium also water, H plus plus OH minus, because everything is dissolved in water. So it can be written as Kw, that is the concentration of H plus into OH minus. Is that clear? Now if I need to find out the hydrolytic constant KH, then what will be its value? So this is, let's say, equation 1, this is equation 2, and this one is equation 3. That clear? Now equation 1 into equation 2 divided by equation 3, what I will get over here? Equation 1, CH3COH OH minus divided by, sorry, here this KH, that can be CH3CO minus, okay, divided by CH3CO minus into equation 2. Tell me, CH3 CO minus into H plus upon CH3COH divided by KW. That means I can write 1 by H plus into OH minus. Clear? So that implies here I can write equation 1, that is KH into KA upon KW, that will be equal to C3COH, this one get cancelled, this one get cancelled. Now this OH minus and OH minus H plus OH minus H plus OH minus H plus OH minus H plus, all everything get cancelled, so that is equal to 1. So that implies KW, that is equal to KH into KA. Now you tell me what is the value of KH? So KH becomes, hydrolytic constant becomes KW by Ka. In this case, the equation for hydrolytic constant KH, that is equal to KW by Ka. Now let us find out the degree of hydrolysis. Degree of hydrolysis, that is H. Clear? So I am again considering this equation, the hydrolytic equation, CH3CO minus plus H2O giving rise to CH3COH plus OH minus. Clear? So initially, if this is C molar, then 0 and 0. So at equilibrium, so what I will get? C minus CH, where H is the degree of hydrolysis for 1 mole, for C mole CH, remaining C minus CH. So here it will be CH. Right now, the equilibrium constant KH, hydrolytic constant, that is the concentration of acetate ion, that is CH into CH OH minus upon CH3COH, that will be C into 1 minus H. So CC get cancelled, that will be CH square upon 1 minus H. Since I am considering the weakest component, that means H is very less than 1. H is very less than 1. So KH, that can be written as CH square. So that implies H square, that is equal to KH by C. So H, that is equal to the K root over of KH upon C. And what is the value of KH? You can tell me. KW by Ka into C, that is the value of hydrolytic constant. So now you can calculate the pH also. What is the concentration of CH? OH minus CH. Just remember this much. That is calculation of pH can be derived from this expression. Calculation of pH. Calculation of pH. Now what is the concentration of OH minus ion? You tell me. That is equal to CH. So that is equal to C into, what is the value of H? KW by Ka into C root over. So finally this can be written as root C into root C. Root C into KW by Ka root over into 1 by root C. So root C get cancelled. So OH, the concentration of OH minus, that will be equal to KW into C root over divided by Ka. So this is the concentration of OH minus. So now we can calculate the concentration of H plus in order to find out the value of pH. Clear? So H plus into OH minus, that is ionic product of water Kw. Clear? So OH minus ion concentration H plus, the concentration of H plus, that is equal to Kw by OH minus. So now this can be written as Kw upon Kw into C divided by Ka root over Ka, that will be equal to Kw into root Ka divided by root Kw into root C. So root Kw get cancelled, that is equal to Kw by root C, that is the concentration of H plus. So finally you can get Kw upon C, that is the value of H plus, concentration of H plus. So H plus ion concentration, that will be equal to Kw into Ka, Kw into Ka divided by C, root over of this much. Clear? So pH you can calculate by considering negative logarithm of H plus ion concentration, and that should be equal to, let me write down over here, what is the expression for pH. So pH, that will be equal to minus half log Kw plus log Ka minus log C. So this is the expression for pH. Okay. So for today's class, this much, and these are not involved in your syllabus. You just understand the meaning of salt hydrolysis, and these are the different formula. How can you calculate pH, pOH for different salt category. One of the salt I have discussed here, rest salts are also there, but these are beyond your syllabus, so don't worry for that. Okay, so thank you for watching.